All right, guys, so today we are going to be putting some of these derivative formulas into action. So first of all, using the derivative, if we're looking at finding the equation of the tangent line and a normal line to a given curve. So it wants us to find the equation of the tangent line at this point right here. So going back to one of those first units that we did, I don't even know how long ago that was. Remember, to find the tangent line, you need a point and the slope at that point. So let's start with the slope. If I have my function right here, the slope at that for that function at any point is going to be the derivative. So I want to find f prime of x. So I'm going to use those rules that we learned. I'm going to take the derivative. Here's mostly just a sum and difference rule. So x cubed, the derivative of x cubed is 3x squared. The derivative of negative or minus 2x squared is going to be minus 4x. 1 over x, we might need to rewrite that as x to the negative 1 to see it. But the derivative of x to the negative 1 is negative 1x to the negative 2, remember, which is negative 1 over x squared. So this becomes minus 1 over x squared. And then the derivative of negative 3 is nothing. It's a constant, so it's just 0. So here is my derivative, which, remember, gives me the slope at any point. So if I go ahead and plug in x equals 1 to this formula, then I get f prime of 1 is going to be 3 times 1 squared minus 4 times 1 minus 1 over 1 squared, which just becomes 3 minus 4 minus 1. So 3 minus 4 is negative 1, minus 1 is negative 2. So that's going to be my slope at this point when x is equal to 1, which that gives me the slope. Now I just need the point. I need the y value before I can plug it into my formula. So let's plug 1 into our original equation to get our y value. So this becomes 1 cubed minus 2, plus 1 over 1 is just plus 1, and then minus 3. So 1 minus 2 is negative 3, plus 1 is, no, 1 minus 2 is negative 1, plus 1 is 0, and I'm left with negative 3. So the point that I'm going to use is 1 comma negative 3. So now I use my point and my slope, and I plug them into my point slope formula. So y minus y1 equals m times x minus x1. So y minus negative 3 equals m, my slope, negative 2, times x minus my x1, my x point, which is just 1. So if you want to simplify, that right there is great on the free response. If you needed to simplify it, this becomes y plus 3 equals negative 2x plus 2. So you get y equals negative 2x minus 1. And you could check that if we went ahead and graphed that function. If I go y equals, and I say x cubed minus 2x squared plus 1 over x minus 3. If I graph that, and my window is going to be messed up because of stuff that we're doing another day. Let's go ahead and zoom standard. See if I get a little bit better view of my graph. There we go. Now I'm interested in my tangent line when x is equal to 1. So I do second draw, tangent, remember hit 5, and we want x to equal 1. And hopefully I get that same answer. So there's my tangent line. And I get negative 2x plus a negative 1, which is negative 2x minus 1. Now to find the equation of the normal line, that's not something we've done yet. Remember, the normal line, what that means is the normal line has a perpendicular slope to the tangent line. And in this picture, you can see it right here. It's this green line right here. It's perpendicular to my tangent line. And to find that, remember, to find a perpendicular slope, you take the opposite reciprocal of your slope. So if my slope, let me scroll down a little bit, give us some space. If our slope is -2, I take the opposite reciprocal, which means I change it to a positive and I flip it over. So my slope is 1/2. So my function, or my formula here, is going to be y minus, same thing, -3. We're using the same point, but instead of a -2 slope, we have a slope of 1/2 x minus 1. So you get y plus 3 equals 1/2 x. 1/2 times a -1 is a -1/2. And if you add that 3, you get 1/2 x, or I guess we're going to minus that 3. So that's going to be -7/2. So that would be the formula for your normal line. And again, back here, I would be okay with that on a free response. You just may need to simplify it more than that to match it up with a multiple choice question on the multiple choice part of the test, okay? All right, so motion, which is one of the biggest uses of derivatives in calculus, is when you're analyzing the motion of objects. And today we're just going to focus on the motion due to gravity specifically, but really the concept carries over to a lot of other topics. So when an object is subjected to gravity, its position function is given by this formula. So the position of an object is equal to -16 t squared plus v naught t plus s naught. Now t is in seconds, it's time. The v naught, so this is time. The v naught is our initial velocity. So what was the speed at the initial starting point? And s naught is our height, because we're dealing with gravity, but it's the initial position, okay? So what's cool about calculus when you're dealing with position formulas is if I were to take 2 different points measured in time of this. So if I have a point here and a point here on my graph, and I wanted to measure the slope, the average slope between those 2 points, that average slope is going to give me the velocity. It's going to give me, because I'm finding what is my average rate of change, and rate of change is just velocity. So what's cool about this is if s of t is my position, then the slope at any point of my derivative gives me my speed, my velocity. So I can say that my velocity at any point in time is equal to the derivative of my position. So that's going to give me my velocity, which velocity can be positive or negative. If you're going up, it's positive. If you're going down, it's negative. But be careful, because speed, you take the absolute value of your velocity. Speed doesn't have negative values, but velocity can. It just tells us that it's going down, because that's the direction that we're going. And that's what it gives you here. It tells you that the formula for velocity is -32t plus v naught. So if I just took my -16 t squared plus v naught t plus s naught. So this is my position function. Now, if I take the derivative of that, s prime, I'm going to take the derivative of -16 t squared, which is -32t. The derivative of v naught t is just v naught, and s naught is just a constant, so that goes away. So this formula right here is what it gives you. Where'd it go? Right here. That's how they came up with it. They took the derivative of the position function. And if you go one step further, if you took the derivative of velocity, if you took the derivative of the velocity formula, you're going to get a formula for acceleration. How much are you accelerating at a certain amount of time? So a couple of things to keep in mind. we're going to use these formulas to solve some gravity problems. If you need to find the maximum height of an object, so if I have an object that's going up, 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 and then it changes direction and starts coming down, at this maximum height, my velocity is 0 because I'm not going up or down. For an instantaneous moment, my velocity is 0. So if I'm ever looking for maximum height, I want to look at the velocity being equal to 0, okay? To find the speed of an object when it hits the ground, well, if I have an object coming down, it hits the ground when my position is at 0. So when S of t is equal to 0, that's the moment that I hit the ground. So if I can figure out at what time that happens, I can plug that time into my velocity formula and figure out how fast I'm going. So let's try a couple of these. We'll do a few here on the video, and then we're going to do some in class as well. So Harry the Hippo, he's diving off a 32-foot high diving board. He jumps up with an initial velocity of 16 feet. Now this formula right here, you guys really need to memorize, okay? That formula, so we're going to put it right, let's put it right here. S of t is equal to negative 16 t squared plus v naught t plus s naught. Okay, this is one that you're going to have to go ahead and memorize. So 32 feet high, well, that's my s naught. And 16 feet is my initial velocity. So that's my v naught. And before we do A and B, I want to look at a couple questions here. What is my velocity function? Well, my S function, my position function, is negative 16 t squared plus my initial velocity, which is 16, times time, plus my height, my S naught, which is 32. So that's my function, my position function. At any point in time, I can plug in a number of seconds and figure out where Harry the Hippo is at in his dive into the pool. So S prime, remember that equals velocity. So I need to take my derivative of this function. So I drop the 2 down and I get negative 32t. And my plus 16t just becomes plus 16. So this is my velocity function right here. So it says, what is the velocity after 1 second? So if I take, what's my velocity of 1? I just take negative 32, times it by 1, and add 16, which becomes negative 16. So what that tells me is at 1 second, Harry the Hippo jumped up and is now going down. And after 1 second, Harry the Hippo is going down at a velocity of 16 feet per second. So the speed is 16 feet per second. The negative tells me that Harry's going down, which it's a hippo on a diving board. Of course, Harry's going down. Number 3, when will Harry hit the water? So we want to know at what amount of time does Harry hit the water? And remember that the position we want to be 0. So we want S of t to equal 0 because that's when Harry's going to hit the water, because that'll be at the height of 0. So if I take negative 16t squared plus 16t plus 32, and I want that to equal 0. So I'm going to rewrite this so that my 16t squared is positive. So basically, I'm just going to move everything to the other side. 16t squared minus 16t minus 32 is equal to 0. Now I'm going to factor. I'm going to pull out the 16, and I'm left with t squared minus t minus 2 is equal to 0. And I can factor this one. That's just t minus 2 and t plus 1 still equals 0. So what that tells me is I'm going to hit 0 at 2 different points in time, when my time is 2 and when my time is negative 1. Now, in the context of this problem, at a time of negative 1 doesn't make any sense, because technically that would be when Harry the Hippo was going up to the top. So we're going to ignore the negative time, and we're going to focus on when the time is equal to 2. that's when Harry's going to hit the water, because Harry's position will be 0. Look at me assuming that Harry is a boy. Maybe Harry's a girl hippo. I don't know. She's got a big swimsuit on up there. What is his speed? Oh, there's the he. And it said it up here. I'm not assuming anything. I'm just following directions. What is his speed when he hits the pool? So now I'm looking for the velocity when he hits the pool, and I know he hits the pool at 2 seconds. So my velocity at 2 seconds is equal to my velocity formula, which was negative 32 times t, which is now going to be 2, and then I have to add 16. Okay, I'm just using this velocity formula right up here. So that equals negative 64 plus 16, which is equal to what? Negative 48, and that's feet per second. So what that means is Harry is going down at 48 feet per second. So my velocity is going to be the absolute value of that negative 48. So it's going to be 48 feet per second. That's how fast Harry's going when Harry hits the water, which is pretty fast if you think about it. You're falling 50 feet per second. You're moving pretty quick. The other question says, how high above the pool does Harry get? So remember, our maximum height, to find our maximum height, that happens when our velocity equals 0. Because you're going up and then you switch directions and start coming down. And for just a moment, you're at the maximum height. You're not going up or down. You're stopped. You're not moving at all. So if I say my V of t formula is negative 32t plus 16, and I want that to equal 0. So if I move the 32t to the other side, it becomes a positive, which means that t is going to equal 1/2 when I divide by 32. Okay, so what that tells me is at the time of 1/2, I'm going to reach my maximum height, or Harry's going to reach his maximum height. So now that I know the time, I can plug that into my formula, my position formula. So my position at 1/2 is equal to negative 16 times 1/2 squared plus 16 times 1/2 plus 32. So let's go ahead and just plug that in right here. Let's go negative 16 times 1/2 squared. And then I need to add 16 times 1/2. I'm just going to put 0.5 this time. Whoa, I forgot we need to add negative, nope, positive. We're adding. Oh, that's what's happening. I'm inserting. Okay, couldn't figure out what was going on there. I'm adding 16 times 1/2. Why do I have so many parentheses here? Those are unnecessary. That's all right. Plus 32. Come on, let's get this over with, right? That's my position formula. So when I plug those in, I find out that the maximum height is 36 feet. So that means Harry the Hippo gets 4 feet higher than where Harry the Hippo started, okay? Now, we've got another problem here dealing with a silver dollar getting dropped off a cliff. We're going to do this one in class, I think. Let's do a couple of problems right here. And I'll try and get through these a little bit quicker so you can, examples are the easiest way to see some of these concepts be put to use. So in this problem, it says Ted jumps from a bridge into a river below and hits the water in 2.5 seconds. How high is the bridge and how fast is he going when he hits the water? So the first thing that I've got my two formulas. I've got my S of t. We know that that is negative 32t squared. No, it's negative 16t squared. Negative 16t squared plus v naught t plus s naught. Now, in this case, if he's jumping off the bridge, it doesn't say anything about him jumping up. So we're going to assume that his initial velocity is 0. So my position is just going to equal negative 16t squared plus s naught. And s naught is the height. That's what we're looking for, okay? Now, I know that he is going to hit the water in 2.5 seconds. So when s is 2.5, it's going to equal to 0. So if I plug that information in right here, I can say that negative 16 times 2.5 squared plus whatever my height is, that's going to equal 0. Okay, now I just need to get S naught by itself. So S naught is equal to 16, 2.5 squared. And if we just want to plug that in, 16, 2.5 squared. That tells me that my S naught, my initial height, is 100 feet. Okay, so I knew how long it took me to hit the water, or Ted to hit the water, and so I can figure out how high he is. Now, if I want to know what his speed is when he does hit the water, I need to use my velocity formula. So I need to find out v of t. Well, we know that s of t is negative 16t squared plus 100. Now, if I take the derivative of that, my velocity is going to equal negative 32t. Oh, sorry, and it's 100 plus 100. Nope, not plus 100t. This is not our velocity. This is our height. So my derivative is just negative 32t. So if I plug in my time, 2.5, I get negative 32 times 2.5, which is going to be, what, negative 64 plus another 16. So it's going to equal negative 80, which that's my velocity. But we don't like a negative speed. So I would say that he's going 80 feet per second. That would be my speed, because it's asking for speed, not velocity. Even though my velocity is negative 80 feet per second, my speed is just the 80 part. Okay. Now the second one here, a rocket gets fired vertically from a rocket launcher and it has to reach a maximum height of 900 feet. Find its initial velocity. So we're looking for V naught. And in this case, if I have my formula, S of t is negative 16t squared plus V naught t, which is what I'm looking for right here. Now my height, it sounds like it's just getting launched from the ground, from a rocket launcher on the ground. So I'm going to set my height equal to 0. Now what it tells me is my maximum height is 900 feet. So I need to get my height. I want my position. I'm looking for, when does this equal 900 feet? When is my position 900 feet up so that I can figure out my velocity? Well, I need my velocity formula to figure out my velocity. So V of t, if I take the derivative of this function right here, I get negative 32t plus V naught, right? Because my t goes away when I take the derivative. And now my velocity, I'm looking for the time when I'm at my maximum, which means my velocity is going to equal 0. Okay, I want my velocity to equal 0. So my velocity is going to just equal 32t. Because if negative 32t plus my velocity is 0, if I move the negative 32 over, my velocity is just 32 times the time that I've been going. So I can go ahead and I can plug this in as my velocity right there. So negative 16t squared plus 32t times t, don't forget that other t, equals 900. Well, negative 16t squared, this is plus 32t squared, equals 900. So that means negative 16 plus 32, that's just 16t squared equals 900. So if I divide by 16, then my time squared is going to equal, what, 900 divided by 16. And it's not going to be a nice number. So let's leave it like that. Let's leave it as 900 over 16. But to get my time, I've got to square root both sides, right? So if I take the square root of this 56.25, or I can put in my fraction, then my t is equal to positive or negative 7.5. And again, we're going to ignore the negative because we're looking at time ahead, not time in the past. So at 7.5 seconds, I'm going to reach my maximum, okay? Which is going to be, which I can plug in to figure out my velocity at that time. So V naught equals 32 times 7.5, which is going to equal 32 times 7.5 is going to equal 240. So my initial velocity is going to be 240 feet per second. That's how fast the rocket needs to leave the ground for it to hit 900 feet in the air.